Alright guys, so we are back at coding the SQLITE monstrosity. I've tried to switch off my audio device. I'm going to use my AirPods for the mic today. Hopefully that should make it better. I had some complaints last time. But regardless, we left off with me figuring out we need to parse SQL statements. And we need to write like a tokenizer and a parser. What I did in the meanwhile, like after that, was I went ahead and I wrote a little more code from what we had before for the SQL parser between my lunch break at work. And we're gonna aim for like an hour of coding today to sort of just, like finish at least the tokenizer, right? So most of the tokenizer code is done. I had explained that the tokenizer creates like these like subunits, like these atomic units from like a sentence, and then gives them sequentially to a parser, which then creates a hierarchical structure, which carries the meaning of what operations in SQL are. So the tokenizer can also be called Lexer, which is the word I've gone for over here. Um, let's just see where we left off the code. So I think everything till here was covered. We decided we need to create a Lexer, we need to create a parser which uses Lexer, and then we need to interpret the abstract syntax tree that gets created based on our SQL query. Our case is fairly simple, where we only deal with create statements, but we want to be very good with how we parse it. And the reason for that is this, because why not? Why not learn how to write a parser? So the first question I had, right, was what are these units that we're talking about? Well, I guess we have these keywords, right? So like create is a keyword. It cannot be something that you use for a table name unless like you quote it in literal. So in a create statement, the keywords that we're dealing with are create, table, if not exists, open parentheses, close parentheses, comma, period. And then over here, I've written a special one, which is going to symbolize the end of the token stream that the parser will be using. You also will notice that on line 34, we have this guy, literal string. So if you're not familiar with Rust, these are like enums in Rust, unlike enums in like C-based languages that you've probably worked with, can hold data. And what that lets us do is it lets us create like a collection of things that are that are not homogeneous in nature, right? So now I could have a string that is held out of a literal enum, but I could also do something like, and this is just for an example, right? I could have the table hold I32, and now I could create, well, this is like incorrect syntax. It's probably going to say like, hey, what the heck are you doing? But let data is equal to, right? We could create some structure, right? Like a vector of tokens. And now what this is doing is it's holding a heterogeneous list in memory. Now, in statically typed languages, this can get fairly tricky to do without wasting space. So you can still do this without using enums, right? But then in your memory layout, like on your RAM, the C way to do this would be to have something like struct, you can have an enum, and then you have for each type, right? So let's just say, God, I don't even know how to code this type anymore. So this would be, let's just say type, and then you would have potentially like a string or char stir, right, followed by int blend, like data, right? So you could have data int or something like that, and then you can keep going. And now based on your type, you'd only assign one of these. But in your memory layout, what you would deal with is the fact that it needs to allocate in like to place this on your RAM, it needs to allocate for all of this. Whereas when you're using an enum, what you could do is it will only take the size of the biggest data type, and then lets you lay out. Or at least that's how one of my mentors, Jim Warner from Microsoft, explained it to me. Again, I have had the privilege to work with super smart people who explain this stuff to me all the time. But anyway, let's get back to the tokenizer, Lexer. Now, the job of the Lexer, right, is to provide, just as we spoke before, very simple APIs, right? Get me the current token, and this is a stateful This is a stateful. I want to use the word object because I code in C# like for my actual job. Um, and so I'm just going to call it object. Like this object has the following methods: get, current token, and peak. Uh, it's a stateful one, so it maintains position in the token stream. Well, it creates a token stream from the string as the APIs get called. Now, because we're in the same Rust module over here, you see I'm not doing this pub function. Um, had I been in a different module, I would have to declare these public, but I do not need to do that right now, so I'm not going to do it because the Lexer is just used by the parser, which is also in the same module for SQL parser.rs. So SQL parser, the module, rs is the file. Anyway, also real quick, disclaimer: using these glasses, blue light glasses, if you're coding at night, it helps to have these on. Helps me go to sleep afterwards much easier than not using them at night. Anyway, let's get back to code. So get current token and peak. So I spoke about this earlier. Get current token, sort of like unless you advance forward, it just lazy reads what you've already read from your string. Unless it's not there. In that case, what it needs to do is it needs to go through the string and say, all right, from 0 to what index would I have to traverse till I get an identifying token. And the second it gets that token, it says, hey, return that token. It sets it, and then it returns it. Now, the next time we call it, it's sort of already in memory, right? So, well, everything's in memory in this program right now. But what I mean is it's already computed. It's already computed. It's stored as a reference. So it just returns that. We don't return a reference. We return a cloned version of that token. And the decision to clone it or not, honestly, we can revisit it. When I write something for the first time, I just use clone as much as I can, and I probably write code like I would in a garbage collected language. And then I come back and I'm like, all right, let's remove clone over here. All right, can we actually let go of this, the ownership of this variable, and give it off to whoever's calling it? So those things come in question. But right now we're not doing that. We're just going to use clone. We also have peak, which doesn't really advance the token pointer, but it lets you get what the next token would be. And it's very similar to the last one, except we're working with two references, current and next, and in peak, we do that. Advance is the method that we call in Lexer that moves it forward in its token stream. And I think this is probably not the most common way to show how it's done, and it may be confusing for people who are not familiar with Rust. Rust has some issues like ideas of ownership, which I wanted to be compliant of. And what I'm doing is that over here, or what take does, forget what I'm doing here or take, right? The core concept that we're trying to go for is this. So you have a current token, right, that has some val. We have the next token that has some val, or maybe no val, because the caller of this or the owner of this object only ever used get current token. It never called peak, so peak never populated next token, right? So some val or none. Now, what we're supposed to do over here is that we want some value to become null, or not null, none. There's no null in C#, and we want the previous next value to become the current. What we're doing by this is we're saving the need to replay and reread the last token, because when you move forward, if you're maintaining 2 pointers, you're basically just saying, hey, move this guy here. Well, 2 pointers, right? We evict what we held over here before. We move forward, and we just take this guy over here that was already there as the next token, as the current token, and the guy next in front of it is now none. So take basically does that. Right? What take does is, given an option type, it returns you the value, and it takes the value from, it takes the sum value that next token is storing over here, and it is going to return it. But also it's going to mutate the what was being held by next token itself. It's going to replace it with none, and that's how you end up with sort of doing that switch, except in a much cleaner manner, which is in one line over here. Now let me quickly put my do not disturb on my watch. Okay, there we go. I also have what do you call Uber Eats showing up in an hour, so we are actually limited to coding the Lexer in the next hour. I'm cheating a little bit over here because I've coded the easier parts of it and I left the hard part of it for you guys to help me with. So read in token. So as you can see, both get current token and peak are relying on this read in token over here. What read in token is supposed to do is when it's called, it advances the index. So we're storing the string in the Lexer, right? And we also store the index of where we are in that string, and it reads it and gives you the next token, and then it proceeds. So that's sort of what we're working with over here. Now let's start with taking a look at how we have. So based on the position we're in, we get a current character, and off of that we can sort of we can confirm what is the expected token that's supposed to be there. So if you see an open parenthesis, well, advance the pointer, return open parenthesis. That's about it. So these are some of the easier scenarios, right? Like these are super easy. I'm actually really proud of this one over here, which is the skipping the white space. And I'm proud of it because I once took an interview where I actually pretty much failed the interview with this step, where I needed to do something recursively, and I could have just kept my code so much simpler had I just done this back then. But all skip white space does is it just advances the character position and calls read in token again, which is itself. So the next time if it sees white space, it skips it again, it goes forward. If we just give it a string of white space, it's just going to give you EOF. It's going to like end of file. End of file is what I'm using for like ending the token stream, right? The token that marks the end of everything. If there's something before that, it will read in that instead of going in here. The next time it will go in one of these arms of these are called arms, yes. One of these arms of the what's it called? Match statement. There we go. I was going to call it switch statement out of habit, but I'm trying not to. And as you can see, I'm doing an implicit return over here. Perhaps we could make it explicit, right? So let's try that. Just because it sort of makes it very clear that this is a recursive call. So there's that. Now I still have some code that I haven't implemented. Tab to view. One second. All right, guys, I'm gonna pause this real quick. I gotta fix my Uber Eats order, and then I'll be back in a second. All right, we're back. Just some Uber Eats stuff I have to figure out. But where were we? Yes. So I was coming to the part where what happens when you have a token that's more than a character, right? You can't just do a quick update on the index and return the token that we know it is. In that case, what I've written is, and I think this is actually a standardized way to solve this problem, right? Read keyword. What the point of this function, or the point of this like method that I have not implemented yet, is it checks if based on, okay, so we know if it says C and there's no open parenthesis, opening what's it called, quotation before it, we know it's the keyword it should be is create, right? So what this checks for is it goes ahead, it moves the pointer forward, right, and checks if we're actually looking at create. If it is create, returns okay, otherwise it bails. So bail is using anyhow, which is a create in Rust that just lets you write a little bit lesser code. And what you are getting out of it, this is just the same thing as returning error. But instead of doing that, it's using bail. So it's cleaner code in my opinion when you're looking at this. Similarly, we're doing the same thing for table. So table can be lowercase or uppercase. So read keyword. Same thing for if, not, and exists. Now, at some point, we also have to deal with literals, and literals are tricky, right? So literals would be things like numbers, strings, blobs, etc. And they're tricky because numbers itself, right? They're the way SQLITE tells you what they're allowed to have is pretty mind-numbing. Let me see. I should have this pulled up somewhere. Literal values, exactly. So the rules for a number, like these are the freaking rules, and we need to code this out. Like this is its own thing that we're gonna have to code out today, and we will. But yes, I just want to show you quickly what we're looking at for being able to extract numbers. And that's just numeric literals. What about, the other literals like string literals, blob literals, null, true, false? Actually, null, true, false, when I think about it, these are nothing but keywords. We could do null, true, false, current time, current date, current timestamp. Yeah, you know what? Let me just copy these guys. Let's see if I can copy this without messing it up. Okay, current date is how far I can go at the moment. So before we get to before we even get to actually coding the the tricky literals, right, which are numbers, strings, blobs, the stuff I just showed you guys. Here, I'm just putting this for reference, right? Now, I do wonder if I could actually write all of this code by having like some sort of lookup table lambda. Okay. So let's see, right? The way I would do that is based on this. I know what we're trying to do. Let's see. So real quick, I see a pattern that we have over here. So I'm just going to quickly work on extracting all of this code, and we're going to replace this with a one-liner that we can then use anywhere. Right. So let's see. What is this function to be called? Jeez, Copilot is just going off, but I don't trust it. I don't trust it because like I spend more time debugging it than like writing freaking code half the time. So I am going to figure out how to extract that code, make it equal, and then go ahead. So we have read keyword, right? But we also could do read and return, right? Read and return, right? Yeah, let's stick with that for now, right? Expected, and at this point, expected string. You know what? We could just take a reference to a string. Wow, it knows that I was looking for something case sensitive. Ooh, okay. You know what? Let's just look at the read and return. Yeah, Rust. Copilot does not do the best with Rust. So expected characters. Okay, expected current character. While let some expected characters next match current character. If case sensitive, if C is not the expected character, otherwise lowercase. Return false. Okay, that's actually correct. If it's none, ooh. Okay, so we're iterating through the expected character. What the fuck? Where's C coming from? Match current character. Where's current character? Like, where did we get current character? Oh, okay, cool. I see it. Here's current character, and at 191, they're just resetting current character. That was my bigger concern, right? They're moving forward, checking it, and as it goes ahead and gives you that. So at 172, token. So this should tell you the token that, well, if everything works, give me this freaking token, right? So, oh no, why won't? Okay, there it is. So if everything works, I can just do this, the result token. And the reason I'm wrapping it in result is because it is gonna help me shorthand exit on my code. So unexpected character. Let's see. If C is not the okay, yep. So okay, unexpected character. C does not equal unexpected character. So same thing over here. If okay, in this case, I feel like we could do a different one, right? If the current character is none and the expected character is still something, fail. Let's see. Length of expected string does not match the input strings does not match the input string. Yeah, okay, that's actually good enough for what we need. And at the very end, what we can do is we can just return the token back. So it takes ownership and it returns it back. Okay, cool. I think that makes sense to me. Why do I have to make this mutable again? It is because I am actually proceeding with line 190. So read and return. Okay, let's go fix this. So read and return, read and return. Okay, so this would be token exists. Awesome. So here, will that work? Let's not. Okay, let's read and return. Oof, why is this complaining? What is the letter saying over here? Operators cannot do result token anyhow. Cannot convert from token to. Oh, simple. Okay, cool. That actually makes my life easier. There we go. This one would be not exists, but this should be just not. Okay, there we go. All right, let's get this guy up. Let's post him 3 lines up, 3 lines up. So case sensitive false. It is not case sensitive. This is also false. Token becomes not. Whenever I read the word not, I think of the Borat freaking joke where he is talking about what's it called? Like when he learns a not joke, he does not know what is a not joke and what's not a not joke. It's just anyway. Borat will probably get me cancelled before my YouTube even has a single view, so I'm not going to use Borat as any form of humor over here for now. And then maybe if I'm famous, I can start using it as the expected humor on this channel. But right now, I just want to throw it in. Honestly, like when you have something in your, like when you're working on something and you suddenly see like, oh, I can actually shorten this so much more like this, it's so freaking fun. It's so freaking fun. Guys, I forget what it's called, but there's a way you can do this, which makes this even more, makes this even faster to do. But I'm just not gonna I'm not gonna go down that road right now. If we could have, right? So based on, and that's actually what the code was probably like. It's switch statements would be like a pointer to a function, or like what to execute next, right? Like even more concise way to do this would be like a hash map that has a function it points to, or a hash map that stores these arguments. And instead of doing like a statement for all of these, we just have a quick look at, oh god, that's going to be so beautiful. We are totally going to give that a try today. So let's see. So the next one is the create statement. So the create statement would look something like this. Create this expects to be created. And then these guys, I mean, they don't really count. There's not much code over here that I am concerned about or care for. You know what, guys? We don't need to write the whole lookup thing that I was talking about because there's only 1, 2, 3, 4, 5, and then I would have to add a hash map in here that does that stuff. Oh, but there's actually not 5 because I still haven't implemented null, true, false, current time, current date, current timestamp. So let's go do that. You know what? We do need this. So how would this look like, right? We would do some sort of match, and then after match, right, we could do, this is where it actually starts, right? The condition in which we go into this one would be character exists in hash map for read return keywords. Okay. Now, I'm not sure how to code that out, where an ARM can have that complex of a statement. But I have a feeling we can do it. I just don't remember exactly how. Okay, cool. Here's how we're gonna do it. Let's make on line 91. Let's make. Let's see. So what are we looking for? Right? We're looking for read return read keyword lookup, and it knew exactly what I was looking for. Okay. Can I actually have a hash map instead of a freaking? Let's see. Hash map new read underscore keyword lookup dot where are the methods on the hash map? I know there's no macro that I can use, which is something I would very much like, and I think I could maybe work on that at some point or see how other people do that in Rust. But we should have something that helps us not have to do this one at a time. So let's see. Okay. Yes, this is something Copilot does really well, which is it sees that I am incapable of doing autocomplete myself, so it does it for me. All right, now this is where it gets fun because all the code that I had over there is actually just going to be removed, right? And so I decided to do there, right? And let's go back further, peek. Nope. Where is it gone? Okay, there we are. So let's go ahead and add these guys, right? So similar to how we're, and this is why I actually decided to make it work like this, because this makes my life so much easier. Read keyword, and I know the literal is, I don't know the literal, but it's slightly in my head because actually, you know what? It is a literal. If the freaking docs for SQLITE, right, are telling me that it's a literal, I will trust it. Oh my god, I'm unable to use my keyboard. So we have insert true. Okay, that's nice. Read keyword lookup, insert false. Awesome. Can you do the rest of it for me? Current time. Yes, that's exactly what I wanted. It makes such a solid freaking autocomplete. It's insane. Current timestamp. Nice. Okay. Um, yeah, that is the lookup table I was talking about. Um, I wonder if you could actually make it a constant, right? Because think about it, right? This lives at compile time, right? Create should always map to token create table. This is freaking compile time. We could make it constant. Let's see if this whole chat GPT thing over here can help us with that, right? So how do I make a hash map of constant values in Rust? I don't even want it to be. I do not want. Do not need it to be mutable. Okay. By using lazy static. No, I don't want to add an external crate to do that. Um, uh, okay, you know what, guys? This is a micro optimization I do not care for right now. There's better things in my life if you want, if you don't believe me like this. I've got so much to do rather than this. Clearly. Um, anyway, let's go do this, right? So, some. I bet you I could just say some match, and then I could do a match on. Yep. Okay, means art. That is actually incorrect. Let's see. Oh, snap. All right, let's go back. So we don't want this to map to this. We want C to actually map to this, right? So what we can do is we can create, we can map this to a tuple, right? So C actually maps to this. And D maps to this. Um, and I would map to this. You guys get it. I'm not going to repeat the whole thing again, like every line. If we see an E, we should have an excess. If we see a, ooh, we have some cool stuff happening over here. We have more than one options when we come across null. Okay, here's what we can do. We can now map this to a vector of tuples. And if any of them is correct, yeah, that actually works. So this can be token literal null to string. Now that's gone. And I put it in the wrong place. Jeez, okay. Well, not entirely. Here, I can just do this, right? Oh my god. Why won't you let me do that? Oh, I know why. I need to be using macro. Wonderful. So this is a vector of tuples which says expected keyword and the token. And I know it looks like I'm doing a lot over here, but I promise in the long term it's actually making my code shorter because this reduces the need for me to add more arms. Not these arms, I mean match statement arms. Alright, so that is. Ooh, where is my Uber Eats? Let me check that real quick. Uber Eats. Uber Eats. Okay, there's some more replacement items, guys. Let's see. Shopping in progress. Glitch arrival by 9:55. It's already 8:58. How long have we been coding for? Jeez, guys. It's so much fun. Yay. Sorry, just had to pull out something like that. Let's see. Can we move forward with this? Okay, why are you complaining, brother? Oh, it's because nope, that is correct. I have a missing opening parentheses. A vector followed by that. Why is my hash map complaining? What the heck? Failed to resolve because of undeclared type. Okay, it's gonna resolve it in a second. I'm not actually completely sure whether it will resolve it in a second, but I think it will. Let's see. Back. Okay, 1, 2, 3. When we come across an F, we know it should say vector, false. Oh no, what did I mess up over here? Yep, I know this guy. So many freaking open and closed parentheses, but the code's actually looking cleaner than I expected. Like, the fact that we have a very clear pattern that we're trying to achieve with this, we're at a good point. It just needs to be coded all the way. Does that look right to you guys? No, it's still complaining. Why are you complaining? There should be 1, 2, 3. There's an extra one. Let me remove that. There we go. And it's gone. Okay, awesome. So F means that it should point to false. Okay, now this is complaining. Oh my god. This is too much. Why are you complaining? You're a vector of tuples. I know you're complaining. You need one more closing parentheses. Do you not need one more closing parentheses? I don't know. So you are this guy. So you are a vector, right, of two tuples. So this is the second tuple. That's a string. This is the closing of the vector. This is the closing of... No, this is the closing of the vector. And this closes the insert statement. Boom. Okay, there we go. But it still won't stop complaining. Why? Okay, thank God, it stopped complaining. Okay, we can leave it dirty like that, and we will come back and fix it. So make this guy a vector of tuples. Give it 1, 2, 3, 1, 2, 3, 4. So let me collapse that down. Alexa, stop. Anyway, now we are looking at... okay, wonderful. So let's keep going at it. Ooh, we have reached a good one. C actually has a lot of freaking copies or copycats. I don't know what to say. So I guess the vector for C, right, has more than one. And oh, beautiful. That's exactly what I wanted to do. Thank you so much, ChatGPT or Copilot, whatever thing Microsoft made. Let's see. Current date time, current timestamp. Nice. Okay. That's coming along. What are we looking at? False over here is done. I feel like we still have some stuff left. Table, if not exists, current date time, current timestamp. Is that all we wanted to do? Was there something else? Is there something else that I'm missing over here? Let's see. Where is that gone? Okay. Null, true, false, and then the other three. Null, true, false, and the other 3 after it's been added. Null has been added, right? So null has actually not been added. Interesting. So let's do that, right? So the second we have someone who can basically, oh, also T has multiple. Okay, let's go make this a lookup table worthy of being called that. Beautiful. Beautiful. One more. That takes care of that. That takes care of. Okay, let's get this guy, right? This stuff over here. So table. Yep, that's its own tuple. All right, so this guy is no longer needed. So we have one C, which could potentially mean create, current time, current date, or current timestamp. We have an I, we have an N, which could be not or null, we have an E, we have a T, which could be true or table. Okay, let's quickly take a look at that. Null, true, false. We know null, true, false is there because I just read it. And then we know these three are there as well. So now we're only left with having to parse these guys, which is where the real magic is. Honestly, there's going to be so much freaking code we need to write for that. Why is my hash map still complaining? Okay, let's give it the types that it wants, right? So there's a character followed by tuple of and static stir followed by token. So you don't do that, we do this over here. Why are you complaining? What is hash map saying? Undeclared type hash map. Oh, Sam, I know what this is. We didn't import it. Jeez. Oh my god, I did not need to do any of this. I could have literally just done. Well, it's at least nice to see that without the type inference, I would just be writing wrong types everywhere. Okay, so we have these guys done. Now, over here, c.toString, nope, we don't need that. We can actually just do this, right? So we match. Okay, all right, let's see. What does get? Get should give us the option and we, so not okay, it should be expected, should be args. How do we get the first one? There we go. Is it case sensitive? Are they case sensitive, guys? I don't remember. Where's my thing gone? Did I tell it whether it's case sensitive or not? Create's not, current time's not, current date's not, current timestamp is not, if is not and null are not time sensitive, E exists is not, T is not. Okay, so there's just none of them are freaking case, like they're all not case sensitive, right? So all right, as long as like I don't see any errors over here, I am a-okay, and we will come back and we will fix stuff. This is where we are, right? So args is 0, which does not care about that, and this guy actually takes. Ooh, interesting. Okay, this actually cannot be just a single line thing, because remember we gave it the ability to pursue multiple paths, and this is where it gets really freaking fun. This is like a lead code problem now. Honestly, this is a lead code problem. So we know args are, so args is not even the right word for this anymore. Where is Uber Eats? 98. Okay. Let me quickly check Uber Eats, and I really don't want to get it right now because this is probably the most fun part we're going to be coding. Okay, he's 10 minutes away. My Uber Eats is 10 minutes away. We're going to code this part in 10 minutes. Okay. So potential expected paths, right? So let's see. All that we want is at least one of them, and there's a question of precedence. So let's see. Null, true, false. Okay, if one of them matches up with our, okay, so for expected token in potential expected paths, if, so we can just do expected token, beautiful, that is exactly what I was looking for. And if after doing all of this, right, we can say unexpected. Nice. All right. Why are you complaining, brother? Oh. That is because of that. Okay, cool. So what's happening over here? Let's see this. Right, required by bound, reduced by call. Missing match arm, none. Yes. So numeric string block. Okay, this is, yes, let's go. This makes more sense. So we have one error somewhere over here, which is complaining about C. Why are you complaining? Why are you complaining? Let's see. What is the error over here? Consider borrowing here. Well, we were borrowing before. I only did not borrow because I didn't want to freaking see the error over there. Okay, borrow string is implemented for string required by bound and hash map. Okay, is implemented. I know where this issue is coming from. It's coming from this guy being Amster. Is it? The get is on required by bounded hash map get. The trait bound borrow car. Okay. Oh, snap. I know what this is. Actually, I don't completely know. Don't. Let's go back at a hash map, right? This is actually dealing with the character. So it's either this guy or it's the fact that like not null and those guys are coded the way they are. So E. I think the get is chilling now. See, there we go. That's what it was. Awesome. All right, read literal. So let's see. Lexer's looking pretty good. We got like I think 100 few lines. Like we reduced a lot of the code today in one freaking go because of like look at how much cleaner this is. Like once I hit cargo format. I know there's probably like a shortcut that I have in here that does this for me better, but override. Okay, that's okay. Actually, you know what? Let's see. There you go. Let me actually see Shift Alt F. So Shift Alt F should do that for you. Okay. Yep. Now our code is much better organized. Everything looks fine. There's one error over here that I'm not sure where it's coming from. Token. Okay, cannot move out of token, which is behind shared reference. Yes, I agree. We cannot move token behind. What are we matching on? We're matching on that. So I can just do this. And this is kind of disgusting, but gets the job done, right? Okay, so this dude is actually gone. We've tackled that problem. What we're looking for now is tackling numeric literals, string literals, or blob literals. So let's go look at what a numeric literal looks like. Read and return. Why are you concerned? Are never used. Associated types are never used. No, that doesn't seem to make sense. Okay. Oh, read returns complaining that no one's calling the functions that call it. So like this guy. No, well, that's because we haven't written the parser yet. We're still writing the freaking Lexer, the tokenizer, right? Now, numeric string or blob. What is the create statement? You cannot have a blob literal in the create statement. Prove me wrong. If I'm wrong, just freaking prove me wrong. I don't think I'm wrong about this. You can have a numeric literal, right? You can do a create with something which has a number in it, I think. I'm not sure. Maybe numeric literals literally never used in this part of the code, but it is what it is. Anyway, we're at 9:16, guys. My Uber Eats is arriving in 2 minutes. I want to finish this today. Like I want to do numeric literals and string literals, and it's gonna be quite the journey to get there. But I'm gonna quickly put this on a pause so I can go get my food and go from there. All right, see you guys in like 5-10 minutes. All right, guys, we are back to programming after getting Uber Eats. Anyway, where were we? Let's see. So we left off with everything done in our tokenizer except getting the numeric and the string literal. Now, the numeric literal and the string literal, right? This is slightly tricky. What I kind of want to do is split this into its own function, and this is the back when I worked at Attune, and I'm sorry to my manager, his name was Simon. I remember I used to like be so pedantic, like as a typical software engineer, I was so pedantic about functions not being more than a certain number of lines. I'd go to Simon and say, this is bad code because it's 300 lines long, like the function. And like, I feel there's a bell curve. And you start with like 300 line functions. Then you go to make every function, like every method, 10 lines. And then you go back down and you're like 300 line functions, like let the code be in front of you. And so I feel like I'm somewhere towards the right more side of it, where I've gone past the making every function like separate and small and whatnot, and it's just write the freaking code. And if someone doesn't get it, just read the code. Like you will get it. It's not that hard. Anyway, sorry to my ex-manager Simon for coding that way. I do think about it every now and then. So anyway, numeric and string, right? Let's go look at those. So numeric, literal. We actually already had numeric down. We just need to go find it. Where's string literal? SQLITE keywords. Oh, snap. Okay. A keyword and string code is string literal. Does anyone ever specify what a string literal is, though? I could have sworn we came across numeric literal. We've done that. What we're looking for now is string literal. This is the only place where that's mentioned. Again, numeric, literal value, string literal, numeric literal. Let's see, we're looking for, not for this, syntax diagram, SQLITE language expression. Okay. Bool, cast, correlated, table column names. In and not in. Case the between. Oh, wonderful. Literal values. Literals may be integers, floating points, strings. Syntax for integer and floating point literals, collectively numeric literals, is shown below in the diagram. If a numerical literal has a decimal point or an exponential clause, it is less than -9 quadrillion. I don't know what number that is. Or greater than a floating point literal. Okay, the E character that begins exponentiation clause of a photo can either be uppercase or lowercase. Of course, why not? Why not just goddamn. Okay, it's fine. It's fine. It is what it is. Can be added between two any. Oh my god! Don't freaking tell me. I gotta work with freaking underscores in here. It is what it is. We will deal with it. Okay, a string constant, a string literal. Thank God. This makes some sense. You know what? We could also just do the blob literal. It doesn't seem that hard. String literal. I could also be token. Alright, we're chilling, guys. Here is the definition of a string and a blob literal. Let's go paste that in here and let's go put it out. Right, so let's see, a string literal with things like, okay, so we have C at this point. We have a reference to C. Actually just do a match on C, right? So there's that, and I will do. So this could mean that this is actually a blob or a string. Anything else should mean this is actually also to do. Numeric literal. And so the way we know if it's a blob or a string literal, what did it tell us regarding the blob or string literal, right? Blob literals containing hexadecimal data are not preceded by a single X or X character. Oh, it's not, okay, cool. X or that, okay. So this is string literal, right? This is X or X means it should be a blob literal. And this means should be numeric literal. That makes sense to me. Now we need to find the closing. So what does that look like? Okay. While some while true. Okay. Oh no, what the heck? Okay. If it is that, we keep going. If it is a single quote, you break. If it is none, you unexpected end of it. Okay. Okay, cool. That makes sense to me. The only issue is I'm supposed to also collect this, so. Okay, sorry, I went all quiet on you guys. So over here, what we're doing, right, is we're iterating through from the starting opening quote till we see the next closing quote. Now, I don't know if inside of a literal string literal we can like escape a quote. I'm going to assume we can't, just so we can do the scope. Like we can just code this stuff up. And honestly, yeah, I'm okay with using a while true. Like, it's just so much more intuitive for me to look at this code and be like, yeah, that makes sense. You know, it is what it is. Okay, awesome. That makes sense to me. What am I missing? What am I missing over here? Syntax expression item. Expected expression or item let statement. Oh. Expected expression or item let statement. Let's see. So that should make it simple. Ooh, okay, that fixes that. That fixes this. We can go here. We can do this. Why are you complaining? What's wrong with the while true? Runs for use loop. Okay, cool, cool, cool. That's like a Rust thing that I can deal with, right? Match next car. I'm just going to give it CH as the next character. Let's see, we make it all the way to here, and string literals actually should be declared outside the loop. And now we can return string literal. Yes, string literal is done. Not exactly. Let's go 18 lines above and see what this is complaining about. Why do I have to hover over this? See, if you meant to write character literal, use single quote. Yes. I actually did mean to write character literal over there, so there's that. Good job. Okay. Now let's go 20 lines down, fix our x's. Fix the other x. Haha. Okay, that's looking good. My cat's jumping over my kitchen counter as usual. Still need to do something about him. Do-do. And do-do. Okay. Wonderful. Why is, oh, obviously our string literals are mutable. If you're gonna be pushing stuff on top of it, has to be mutable, and that fixes that. Okay. What are we staring at now? We are staring at. See, the thing is, I find Rust code like so like Like especially the match statements are so clear that I don't need comments for a lot of these things that I don't know, like Python or something. Really, like I remember how much I hated static typing, and I couldn't understand a type system for shit. Then one day I realized how much like fewer bugs I write when the compiler stops me from making stupid mistakes that I kept making in Python. Like when everything is Wild West. Basically, the lack of boundaries makes you like code just incorrectly so often that a language like Rust is the perfect example of like how much further I could go. I could go and like when stuff compiles, it works. You know, like in stuff like TypeScript, that's just not how it works for me. Even if something compiles, it does not seem to work. But anyway, let's see. Now, you know what, guys? What would be really, really cool if a string literal and a blob literal, the only difference is that a string literal doesn't have an X in front of it, right? So we know we're already inside a blob literal. What if I did this over here, right? Where I self dot character position, right? So we skip the X, right? And then we call self dot what method is this? Like what method am I inside of? Read in token, yes. Read in token. Okay. Yeah, what if I just call self dot read in token at this point? Right. And can I do this? And the only acceptable answer that I can get for this guy is that this should be a string literal. So it should be token, which should be a literal, okay. And check if literal is a valid hex string. Oh wow, okay, that's a thing. Token literal, nope. And this is where I do my magic. I can just say token blob. I think my cat is stuck inside of the cupboard. Hey, buddy. Yeah, I think he's okay. He is having that. Okay, token blob literal. Let's keep going from here. Token blob literal. Okay, nice. I was able to use this recursively to get the answer I wanted. Come on, can I save it? Why are you complaining? Why are we complaining? Missing match arbs. Oh, yeah, what if it's not that? Well, fail, unexpected character. Alright, let's go over here. We have literal. The thing is, literal is also kind of a hexadecimal literal, right? Maybe literal should be its own enum. Well, enum, literal. So this would be, literal would be, I don't want to do this. I want to do string literal, right? Blob literal, also string, and then we have a numeric literal, which is also holding it in the form of string for now. I'm okay with that. I just want there to be a distinction. Like I want there to be a very clear distinction. And there needs to be a literal. Okay, so what do I mean by that? So create, yeah, these guys are just literals. They're not, there's nothing I'm too concerned about over here. Okay, we can leave that as it is. We can move forward, make this a blob literal, right? Then make this a string literal. Everything else can remain as literals. And this has to be string literal. and then we get a string literal, we convert it to a blob literal, and we call it hey. So, like that's it. Okay, awesome. Now we are down to our last soldier for the Lexer, which is numeric literal. And honestly, this is where the problem starts. Because there's actually it's not a problem. They've given us a state machine over here. There's our starting point can either be a digit, a dot, or a 0x, or a 0 big X. Okay, how does this work? If it's a digit, it can either be a digit, or it could be a underscore. This is technical. This is pretty hard actually. I could use a regular expression here. I really could. Times 946. Okay. Literal values are done except numeric literal. We will come back to the numeric literal tomorrow, and I will figure out a nice way to write this out. For now, I'm going to call it a night. Part 2 is done. It's going to be like 100 parts before we're done, but honestly, guys, it's okay. I've accepted the fact that nothing worth making, worth my effort, is going to be something that I will be able to code in a week. It's going to take months. It's going to take months to learn how to code Rust better. It's going to take years to be like an expert in systems programming. But you know, we're having fun, and time flies when you're having fun. Like literally, look at this. Like, how many hours has this been going on for? 1 hour and 11 minutes already today. And you know, how much code did we write? I don't think we even wrote that much code, if I'm being honest. Yeah, here. Get status. Let's see. Get status. Start tokenizer. Just 285 lines of code in general, like in those 2 hours that I recorded, realistically. But I'm happy with it. It's meant to take a while. It's not simple stuff that we're coding, or maybe it's simple for others. It's not simple for me today. I'm just happy that I'm at a point where I'm able to whip out Rust without having to look up stuff. And you know, there's definitely some cleanup that this could use. I'm trying to think where else I could have some more cleanup. Interesting. You know how what we did with the read-in token? I think it was over here. No, where's the lookup stuff that I did? This guy. You know how we have this over here? We could pretty much just take all of this code and do that, but I think we're okay without it as well. Let's just put the white space at the top, so it's sort of like the recursive nature is pretty obvious from the very start. Yeah, I'm okay with this. I am okay. Let's see, some, none. Maybe it could use its own method at some point, but let's see. HK to do numeric literal parsing. Okay, awesome. Thank you guys for watching. If you watched it this far, it would be very surprising if someone's watched it this far. So if you did, hit me up. I have a special gift for you for being someone who watched it till this part. And yeah, I will catch you guys in the next part of this, which will be another hour plus. Let's see how this goes. Bye.